Students, in the last topic we discussed Daniel's health, where we simply took two beakers. Lead rod was dipped in ZnSO4 1 molar, copper rod dipped in copper sulfate 1 molar, and the two rods were connected by a wire along the switch, and when the switch was put on, the bulb glowed. It means that chemical energy has been converted to electrical energy. Plus, then we discuss about their nature, about negative and positive. So class, this was my anode. It was negative here. This was my cathode. It was positive here. And we got overall cell reaction Zn plus copper 2 plus, giving me copper 0 plus Zn 2 plus. So zinc was getting oxidized and copper was getting reduced. So whenever you take zinc and zinc sulfate with copper and copper sulfate and you connect by wire, the bulb starts glowing. Okay, after some time it stops, and that we have discussed the salt bridge, that is another issue. But yeah, what the cell reaction taking place? Zn is getting oxidized to Zn 2 plus and copper 2 plus is getting reduced to copper 0. Why this happened? This happened due to cell theory. And the cell theory was, higher the reduction potential, more is the tendency to get discharged at cathode. In class, I have already given this value to you, Zn2 plus oblique Zn0, the value was minus 0.76 volt, and copper 2 plus oblique copper 0, the value was positive 0.34 volts. So class, if we compare these two reduction potential values, we find that reduction potential of Zn is less, so ultimately it is going to be oxidized at anode, oxidation, and copper has higher reduction potential, so copper will get at cathode and will be reduced, reduction taking place. So Zn getting oxidized to Zn2 plus and copper 2 plus getting reduced to copper 0. And how to calculate E0 cell? That is standard EMF of the cell. We will be talking about what is the word standard next topic. So standard EMF of the cell is E0 cathode Rp minus E0 anode Rp. Put the value. Cathode 0.34 minus anode minus 0.76. Open it, you get positive 1.10 volt. Since the EMF is in positive, that's why you are getting the cell reaction spontaneous, and 1.10 volt of electricity can be obtained by putting zinc and copper sulfate, putting Zn and copper plates in their respective flights, and we connect it, we get 1.10 volt of electricity. So you are supposed to remember this very, very important thing, that is cell theory. Higher reduction potential, more the tendency to get discharge at cathode. So if the higher reduction potential is going to be reduced at cathode, then obviously with lower oxidation potential or lower reduction potential is going to be oxidized at anode. So these are basic funda. If you forget this, then it will be very, very hard to understand the entire electrochemistry. So again focus that you should be remembering this point. Higher the reduction potential, more the tendency to get discharged at cathode. To get reduced at cathode. That is much more particular term. Class, what this knot represents? This knot represents standard state. So now we'll work on standard EMF of the cell. This standard word, class, it is coming from your thermodynamics. In class 11, we have studied standard states, and the same standard state is being referred here. So what is standard EMF of the cell? Get the EMF generated when concentration of electrolyte is taken as 1 molar, 1 molar, and if any gas being passed at 1 bar pressure and if temperature corresponds to 298 K, that is your 25 degrees centigrade, then cell is said to be in standard state. The cell is said to be in standard state and EMF generated is called standard EMF. So I repeat again, class. E is represents standard EMF. And what is standard EMF? Is the EMF generated when concentration of electrolyte is taken as 1 molar and if any gas is being passed at 1 bar pressure and if temperature corresponds to 298 Kelvin, then cell is said to be in standard state and EMF generated is called standard EMF. Now class, we'll move to a very important topic that is called electrochemical series. Very important topic, electrochemical series. So what is electrochemical series? If elements reduction potential values, if elements reduction potential values are written in increasing order in a tabulated form, it is called electrochemical series. Class, we are not supposed to remember the entire series, but yeah, you must understand what are the application of electrochemical series. So I repeat again, if elements reduction potential values are written in increasing order in a tabulated form, it gives electrochemical series. Class, I give you very simplified form of electrochemical series. लिख पे काना zinc, iron, hydrogen, copper, silver. Remember only this, because whenever question will be asked to you, reduction potential values will be always provided. It is impossible to learn reduction potential values of all the elements. So simply remember what are the application of electrochemical series. You are not supposed to remember the reduction potential values. But yeah, for your reference, I have got some values here. Zinc just now we have calculated. Hydrogen is taken as standard with 0.00 volt. Copper we already written in Daniel cell. And silver I remember. So these are the things. How to remember? Lick be kana, zinc, iron, hydrogen, copper, silver. Lick be kana, you can very well revise it. Lick be kana, zinc, iron, hydrogen, copper, silver. If you remember this series, I think you remember most of the things of electrochemical series. So now we'll be going on application of electrochemical series. Applications. Identifying oxidizing agent and reducing agent, that is OA and I. As just now we have taken Daniel's cell reaction. What we saw over there, Zn was getting oxidized and copper was getting reduced. And class, remember the cell theory also, higher reduction potential, more the tendency to get reduced. Class, the elements which are placed below, they have more tendency to get reduced. The elements which are placed above, they have more tendency to get oxidized. If they are getting oxidized, so they are behaving as oxidizing agent. If they are getting reduced, they are behaving as reducing agent. So ultimately what we can write? We can write that reducing agents, an element placed below or a hydrogen are good oxidizing agent. I repeat again. We found that copper was getting reduced, zinc was getting oxidized. So copper is placed below hydrogen, so it is getting reduced. Who is reducing them? The elements above hydrogen are reducing them. So the element placed above hydrogen are good reducing agents. Zinc was getting oxidized. Who was oxidizing it? Copper was oxidizing it. So the element placed below hydrogen are good oxidizing agent. So elements placed below hydrogen are good oxidizing agent. So class, I repeat again. Since they are getting reduced, they are reducing them. So above hydrogen are good reducing agents. Above hydrogen, the first one, are good reducing agents. Since they are getting oxidized, who is oxidizing them? Element placed below are oxidizing them. So elements placed below hydrogen are good oxidizing agents. Number 2 is displacement of metal. Displacement of metal. Class, in Daniel's cell reaction, what we saw? We saw that Zn was getting oxidized and copper was getting reduced. So the reaction can be right here, Zn plus copper 2 plus the same Daniel cell reaction giving us Zn2 plus copper 0. So Zn was displacing copper from the copper sulfate solution. So we can say that elements placed above can displace element placed below during the reaction. So I can write here elements placed above, can displace elements placed below. Or in simple terms, ऊपर वाला can reduce नीचे वाला. So the elements which are placed above can reduce element placed below. Then calculation of E0 cell. Class, remember your Daniel cell reaction. We have calculated E0 cell with the help of these two values. There were only two metals over there. Zn was there, copper was there. So with the help of these values, the value which I quoted over there, it came from the electrochemical series. So electrochemical series helps us in calculating E0 cell. So what was the formula? E0 cell equals to E0 cathode minus E0 anode. Both are weak. And the last is finding spontaneity of a reaction. Spontaneity. So how to find out? So class, I am now going to repeat. Finding spontaneity of a reaction. It simply means whether the cell reaction will take place or not. There are three conditions. If E0 cell equals to positive, reaction is spontaneous, will definitely take place and the current can be generated. If E0 cell equals to negative, reaction is non-spontaneous. No current can be obtained if E0 cell comes out to be negative. And the third one, if E0 cell equals to 0. It simply means rate of forward reaction equals to rate of backward reaction. We can simply call it cell reaction is at equilibrium. And since both the reactions are taking place at the same extent, therefore voltmeter reading will neither be towards left nor be towards right. It will simply signify 0. So these are the 4 important applications of electrochemical series. Very, very important for understanding the entire electrochemistry. Now class, we'll move to our next heading, that is called sheet. Topic is sheet. What does it mean? Standard hydrogen electrode. Class, we all know that hydrogen is a gas. Previously we have taken industrial cell reaction, copper rod and zinc rod, but hydrogen being gas, how can we make electrode of hydrogen? So class, concept of adsorption has been taken into consideration here. Adsorption is a attachment of the gas on the surface of the metal. I am going to just tell you, and you have chapter surface chemistry, so adsorption will be very well understood over there. But for today's, we can simply say that platinum foil adsorbs hydrogen on its surface. See how. This is a wire, and this is my platinum foil. PT foil, platinum foil, and this foil is dipped in 1 molar HCl. What I am doing is, I am passing hydrogen gas in the chamber at 1 bar pressure. So what will happen? This hydrogen gas will enter into the chamber, and since platinum is a good adsorber of hydrogen gas on its surface, so hydrogen gas will be adsorbed on the surface of platinum foil. And since this hydrogen gas has been suspended in 1 molar HCl, so that constitutes standard hydrogen electrode. Class, let us remember the basic definition of electrode. When a metal is dipped in its own electrolyte, it is called electrode. Similarly, you find that hydrogen gas is dipped in its own electrolyte, that is HCl. So hydrogen gas dipped in own electrolyte HCl, so that constitutes hydrogen electrode. Why the word standard? Because concentration taken over is 1 molar and the gas is being passed at 1 bar pressure, and just now we understood that standard condition is the electrolyte should be of 1 molar and the gas being passed at 1 bar pressure at 298 Kelvin. That constitutes my standard hydrogen electrode.